Professor Crusoe here, and we are doing interval notation. Interval notation is used quite often in this class, so we need to make sure that we have a good understanding of that. So to begin with, um, we have a solid dot here at A and a solid dot at B, and we have everything shaded in between, or it's a continuous function that we're going to have in between A and B. Whenever it includes this value, whatever the lower value is, if it includes that, it gets a bracket. So a bracket is a closed. A parentheses is called open. Parentheses, open, and then that's the rounded. So this is a bracket because it includes it, and it includes the B, and it's everything in between, so we just put a comma. So A, B. So bracket, bracket, and then we have everything shaded in between there. That's the same thing as saying A is less than X, which is less than or equal to B. So remember, this is less than. It points to the left. And this is greater than. It points to the right. So this one here, A is a solid dot and B is an open circle. That means it gets very, 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 very close to B, but not equaling B. So A is on the left. A is on the left, it's less than. The B, it's smaller, it's the lowest value. So it gets a bracket. And the one on the right side, B, that's where it goes to, is a parentheses. So it's A is less than or equal to X, less than B. So notice it doesn't have the equal to sign, so it doesn't equal that value. If you had two open circles, it would be a parentheses, A, comma, B, parentheses. And neither of them have an equal to sign underneath them. So it's A is less than X, less than B. Also, you could have an A open circle and a solid circle at the B. So again, the A is the parentheses. So it's parentheses A going to B and then bracket, which is the same thing as saying A less than X less than or equal to B. Sometimes it doesn't have anything between, so it keeps going here, goes forever and ever to the left, and we call that negative infinity. So over here on the left side, this is negative infinity. On the right side is positive infinity. Infinity is supposed to look like a sideways 8. I'm not very good at them, so I just to do it quickly, I do 2 circles and do right next to each other to do my infinity. All right. On Wiley, you type in INF, or it might be INFINITY. So infinity if you can't find the symbolic notation. Negative infinity is always on the left. Positive infinity is always on the right. They never, ever get a bracket because infinity is not a value. They always get a parentheses. So here, this is from negative infinity to, and then so this one little part is negative infinity because it's on the left and it goes to A. So I write that part, negative infinity to A, because that's like the shaded part. It doesn't include the A, so it gets a parentheses. Then this next part, it starts at the B. So B, it gets a bracket because it's a solid dot. And then it keeps going to the right forever. So that's infinity. And again, the parentheses. We say this as or. So this is called a union. And a union is an or. Okay. So solve and write in interval notation. Example 5 minus 3x is less than or equal to 23. What we would want to do is, this is just a 2-step equation, except for it has a less than sign. I always keep my less than sign. So remember, this is a positive 5. I'm going to subtract 5 from both sides. Bring down the negative 3x. Keep the less than. 23 minus 5 is 18. Then I would divide by negative 3 on both sides. Some of us do not need to show this step, so I'll rewrite it, showing what we definitely need. When we divide by a negative, Remember, the inequality changes whenever you multiply or divide by a negative, it changes. So this becomes x is greater than, and then 18 divided by -3 is -6. Okay. If you had on your work for a test or a quiz, if you just had -3x is less than 18 and then x is greater than -6, that is fine. You are mathematically sound to have that. What this says is that if we were just talking about a number line, x is greater than -6, here's -6. Greater than means it's an open circle, it doesn't include that. Greater than means shaded to the right. So how I write that in interval notation is on the left side. So this is the lower bound, and then this is the upper bound. So it keeps going. So -6 is the lower bound. So we write the -6, and the upper bound means it goes to infinity. Infinity always gets the parentheses. -6 also gets the parentheses because it doesn't equal it. So this is my interval notation, and then this is inequality notation. Some people do set builder. Okay, interval notation is a big way, and we want to make sure that we practice that. Absolute value of A is less than A. It has two answers for absolute value. So absolute value x is less than A is what that just said right there. If it's less than, it's an and, which is an intersection. So that means what's in common. Most of the time we write that between them. That would be the negative A less than X less than A. So that's how we write a less than. And I'll do the greater than in just a second. If it was absolute value of X minus 3 close less than 7, this would be saying X minus 3 is less than 7. It's also saying X minus 3 is greater than -7. So we write it just between. Because it's a less than, we write it in between the two values. So I have 7 and then its opposite, which is -7. And notice it always goes low to high. If this was -7, the absolute value is less than -7. We can't do because an absolute value is always the distance from 0. So it's a positive number, and a positive number can't be less than a negative number. So if it said that, if it said the absolute value of x is less than 11, this will always be positive. So is a positive number ever less than, oops, I wanted a -11. -11. That answer is no. Okay, not possible. So on this one, now it's like two equations. Over here I have -7, here I have +7, and I want to add a 3. So I add a 3 to that side, and I would add a 3 to this side. When I do that, I end up getting -7 plus 3, which is going to give me a -4. I'm going to keep the less than sign, and then my 3's would cancel out. So here it is. If I added 3, I would get -4 less than x less than 10. So what that's saying is that it's a less than, so I'm on a number line from -4 to 10. It doesn't include the -4, it doesn't include the 10, but it's between them because x is between them. So interval notation is -4, 10 with parentheses. If you had an absolute value of x is greater than, let's throw it to an equal to or a, that's an or. That means x is greater than or equal to a, and I write the word or, x is less than or equal to negative a. This means most of the time you're going to have something where you're going to have your a and you're going to have your negative a on the left, and then less than would be over here. So most of the time it's like on the outbounds. So I put an equal to on this one so they get solid circles. So they're opposite of each other. They kind of spread out. So if you had something very simple, and we said the absolute value of x plus 4, close your absolute value is greater than or equal, let's do it just a greater than 5. So we would write it as two separate ones. X plus 4 is greater than 5, so write it exactly. Notice when I do absolute value, I don't change the sign inside, okay? I don't change any of this stuff inside, nothing. Nothing of that changes on the inside. So then I would have x plus 4 is less than negative 5. I change the symbol, I change the sign. I solve, I'm going to subtract 4, and I get 1. Subtract 4, and I get negative 9. So negative 9 is on the left, 1 is on the right. I did an open circle, greater than 1, and this is x is less than negative 9. So we write that it starts at negative infinity, and it goes to negative 9, so negative infinity to 9. It's a parentheses at 9, parentheses at the negative infinity, union. Then we started at the 1, and we went to the right to infinity. So that is our notation.